So Venkatesh, Gudepu, University of Texas at Dallas, and also affiliated with Future G Networks Lab at IIT Dharwad. He'll be speaking about MIND-ORAN, multi-stream intelligent network drift handling for ORAN. Venkatesh, he goes by Venkatesh, so he's currently working with University of Texas at Dallas. By the way, yesterday, Tracy talked about UT Dallas. They are very much involved in this whole Open RAN, NTIF-funded Open RAN Accord project. I don't know if you're part of that, Venkatesh.
Yeah, Professor.
You are? That's great. I visited when they had the kickoff meeting maybe 2 months back. A lot of good stuff happening there. So his research interests include 5G beyond technology, IML for networks, Open RAN standards, implementation, energy sustainability for beyond 5G networks. He completed his PhD at Indian Institute of Technology, Dharwad IIT, in 2024 with a thesis that focused on drift handling, energy evaluation for open radio access. There was a question yesterday, she's still there in the audience today, about energy efficiency. So prior to that, he earned his MTech in artificial intelligence from National Institute of Technology, Uttarakhand, in India 2020. Research interests have been presented in several high-impact publications. So with that, let's see what you have. You got 20 minutes presentation, 5 minutes for discussion for next steps.
Yeah, Professor.
Thanks.
Hope the slides are
Please share your slide deck.
Yeah, I just shared, Professor. Hope it is visible now.
It's visible.
Yeah. So greetings all. I am representing from UT Dallas and Future Networks Lab at IIT Dharwad. So our team includes me and Professor Gudepu.
Please proceed. Oops, something started happening. Are you there?
Yeah, Professor.
I think your video is getting, we don't see your slides anymore.
Yeah.
You may want to turn your video off if it's a bandwidth
Yeah,
issue.
Professor. Now they are visible. Professor? Hello?
Yeah, we see your slide. Please proceed. Yeah, there was an interruption in between.
So these presentation covers from the very basic, what are the key principles of the ORAN and how the principles of the ORAN, especially about the intelligence, has been enabled, and what are the various challenges while enabling the intelligence, and when you
We lost you again.
It looks like a bandwidth issue, so
yeah,
keep trying.
it is showing that.
Yeah. So Venkatesh, please don't turn your video on. Just keep your video off.
Yeah, Professor. Yeah.
Okay,
So
go ahead.
So we'll look into the key principles of the ORAN, as well as among the key principles, intelligence has been one of the key aspects, and we see how the intelligence has been enabled in the Open RAN, and what are the key challenges while enabling the intelligence that we can call it as the drift. Oh, the Zoom is quitting unexpectedly. And we see.
Should we have him just talk, stop sharing slides?
Yeah. So Venkatesh, we can present the slides from our side. You just speak, okay? I think let's do that when he gets back. Is he on? Venkatesh, are you on? You can come just speak through the phone maybe. We'll just share the slides. I don't know. We cannot hear you, just to let you know. Venkatesh?
Yeah. Yeah, Professor.
So,
I
so
think
wait. So let's do one thing. We have to fix this problem. Otherwise, we'll keep going back and forth. Should we share the slides and you will just speak? That
yeah,
way,
yeah.
let's do that. Nick and Bill, let's share the slides and you just have to tell us next. We'll do that.
Yeah, Professor.
Okay? Yeah, don't share the slides, Venkatesh. So we'll share it. All right, so the slides are coming up. Now you have to just tell me. I will forward the slides.
Yeah.
Okay.
Yeah. Next slide, Professor.
All right.
Yeah.
Next.
So yeah, we'll be looking into the challenges while enabling the intelligence, that especially about the drift occurrence, and we'll just look into the glimpse of the state of the art about the drift handling in the especially 5G and beyond networks, and also uh, like the major gap that we are going to cover and we want to present is that like how can we handle the drift when multiple XApps or RApps uh, are there, and how can what sort of strategies that we need to follow so that we can avoid the drift and see the RAN performance getting enhanced, and the intelligent support has been taken for the ORAN. And we see about some future directions. And next slide, please. So the key principles of the ORAN, if we see like openness, which allows the multi-vendor interoperability so that they can mix and match with the various components from the side in the RAN technologies. And the other key principle, if we see that intelligence, it is to ease the complex network configuration for meeting various dynamic service demands or dynamic service requirements from the users. So towards enabling intelligence, we see various consortia are putting efforts. Among them, we see the ORAN Alliance, Telecom Infra Project, and Open RAN Policy Coalition. And among that, if we see like ORAN Alliance has been like with the various working groups, it is actively promoting the open RAN technology. We see, and for enabling the intelligence, we see the artificial intelligence and machine learning algorithms has been used due to their ability to deal with the complex data and the complex network architecture. So, can you please go to the next slide? So this is where we see about the ORAN architecture. Like this is, if we see mainly the intelligence has been enabled through the RAN intelligence controllers. One is a near real-time RAN intelligence controller, which controls the applications that has granularity between 10 milliseconds to 1 second, and the non-real-time RAN intelligence controller, which operates the use cases that has granularity of greater than 1 second. For example, some use cases, if we see AML model training, AML model offline training, and policy creation, and various other use cases, various applications we see, and various open interfaces also we see. However, the RICS has been playing crucial role in enabling the intelligence in the radio access network. So can you please go to the next slide? Yeah. So if we just see, like, if we try to understand that AML in the context of 5G and beyond networks, if we can see, like, we can broadly classify into three parts, like where in the area of network planning, if we see network element placement, dimensioning considerations for RAN clusters, some use cases or some applications we have seen. And when it comes to the network diagnostics or insights, if we see like efficient mobile traffic forecasting or quality of service improvement, various use cases we see. And the other key one is the network optimization and control. Under that, if we see like optimization at the RAN components and transport layer and network functions, virtualization infrastructure and all. However, it is good that the advent of RICS enhancing the performance of the RAN, but still there are some challenges that we can see. Those challenges we'll discuss in the next slide. Can you please go to the next slide? Yeah. Yeah. So that we see that utilizing AML algorithms through RICS enhancing the performance of the RAN. some challenges which we mainly focusing on the drift. So the drift, we can term it as like the the decay in the AML model performance. So we call it a drift, or AML model performance degradation over the period of time. We call it a drift. But what are the key reasons behind the drift occurrence? If we see that, like in our investigation, as well as based on some recent works, we have listed out couple of reasons. There could be some more. One is the advent of unseen or new user data traffic than the trained one or the observed one. We have trained a model with one particular user data traffic, but in the deployment, while it was integrated and operating in the real time, it has encountered a new user data traffic, which is unknown to that. So the AML model still assumes that it is the historical data only is there. So it comes with some false insights. So that could be one of the reasons, like the advent of unseen or new user data from rather than the observed or trained data. And the other reason, potential reason, could be highly dynamic service demand from the users. So maybe our data has captured only few service demands, but as the key component of the 5G and networks is providing highly dynamic service demands. So that could cause the drift. And some more reasons, if we see like new network service requirements, that could also cause. And the recent paper, the LEAF, has listed out one of the reasons from their observations is the change in key performance indications could be one of the reasons for drift, and also software upgrade and change in network infrastructure also. These are some key reasons that we see, and even these are very realistic that we can observe. So can you go to the next slide? So like it's good. Like we understand that drift can occur. Anywhere we use AML model, drift can occur. Impact, what is the impact of drift, especially in the telecom area, if we see, or in the 5G and beyond network, the consequences drift, if we see, like it can impact on AML dependent applications for decision making. So if we have some applications which are AML model dependent, those decisions could get impact, or they might be impacted because of that. And also the occurrence of drift provides false insights from XApp or RF despite changes in the traffic. If we have trained our XApp microservice app, that XApp over the particular data, but if it is providing some insights to the RAN elements through E2 control messages, but if it does not have an idea about the changes in the incoming user data traffic or any drift occurrence, then it provides false insights. So how could it impact? That if we see like one particular thing, if we see like it could, if there are AML dependent applications that are useful for resource allocation. Now the resource allocation and utilization issues we see, like either resource over provisioning, which could result in waste of resources, network congestion, and increase in the operational expenditure. And it can also result in the resource under provisioning, where the network performance degradation we see, and the increase in the delay and the response times we are seeing. It also indirectly impacts the service level agreement. So we have listed one use case from the TM forum where they have discussed about the smart ambulance use case, where they mentioned like the SLA for minimum and maximum throughput for the smart ambulance use case, we see 25 Mbps and 400 Mbps with response time less than 20 milliseconds. If we employ an AML model to predict the throughput over the period of time, but the drift occurrence can cause the SLA violation, if we see that we can see here. So these are some consequences of drift and their impact and its impact in the telecom area, especially 5G and beyond networks we are discussing. So can you please go to the next slide? So some works, if we see the drift handling, there are several approaches. We have listed out all the approaches under three categories, broad categories. One is the performance based, where the AML model performance has been observed and some threshold has been employed. Whenever the AML model performance, maybe accuracy or reference code recall precision or root mean square error, mean absolute error, or any other thing, any other parameter they consider. And whenever that parameter exceeds the defined threshold, this is that triggers that the drift has occurred. That's fine. And the data stream based drift handling approaches, where it will observe, where the approaches mainly observe the incoming user data traffic and takes a decision whether the drift has occurred. Like some data descriptive statistics they could use, data range, mean, mode, median, standard deviation, variance, and other performance metrics they could use. And the hybrid approaches also has been proposed. But the like these are some of the works that we have just mentioned, like the drift handling framework for Open Radio Access Net, which was our recent work, and the LEAF work is recently from other lab, and the other works we have listed out here. So the key disadvantage here is that all these works are so far in the drift handling, especially for the 5G and beyond, they're focusing on single XF performance degradation or single RF performance degradation, or they're mainly focusing on the single data stream. For example, one of the works mainly focus on the QoS prediction, where they consider quality of service prediction or throughput prediction or any downlink or uplink throughput they consider, and that stream they observe, and that stream they keep predicting, and based on that they determine that drift has occurred or not. But now the question is how to deal with drift in when there is a scenario where multiple XApps or RApps are there, where different streams are there, where different group of XApps are there. How we are going to deal with that? So can you please go to the next slide? Yeah. So when we are just going to discuss about that, I just want to emphasize here. If we see like on the non-real-time RIC, if we see that we have mentioned a couple of RApps, RApp 1 to RApp n, and now near RIC side, we see that XApp 1 to n. Now the scenario is that like how we are going to handle with the drift when there are multiple XApps or RApps performance gets degraded, and what could be the like what are some use cases? Are there any such use cases that involve the multi-stream drift occurrence, or what are the challenges when dealing with multiple XApps or RApps drift occurrence, and how to deal with drift in multiple XR RApps, and with some open questions and some standardized efforts we discuss and move on. Can you please go to the next slide? So here we see some of the use cases, use case scenarios we see, especially first one is like QoS prediction XApp and traffic load balancing XApp. So we are dealing with about multiple XApps or RApps performance degradation. So the scenario here is that the QoS prediction XApp uses historical traffic data to predict the quality of service for different groups. Meanwhile, the traffic load balancing XApp allocates network resources based on these QoS predictions to ensure even distribution of traffic. And the drift occurrence scenario we are discussing here, if the data distribution for traffic patterns changes due to new user behavior, for example, sudden increase in video streaming, the QoS prediction XApp may experience the drift occurrence, leading to inaccurate predictions. And as a result, the traffic load balancing XApp relying on these QoS XApp predictions might make suboptimal resource allocation decisions, causing network congestion in certain areas and underutilization in others. And the second, use case, if we see where the energy management RApp and user demand forecasting XApp, the scenario here is that the energy management RApp is responsible for optimizing energy usage across the RAN using predictions from the user demand forecasting XApp to adjust energy consumption in line with the anticipated network load. Now we see like how the drift can occur here. Suppose the user demand forecasting XApp encounters drift due to a change in user behavior. For example, more users working from home during the day. Now this drift occurrence leads to inaccurate demand forecast, which then cause the energy management RF to either over provision or under provision energy resources. This can result in increased operational cost or degraded network performance due to energy shortages. And we see about the network slicing XApp and service assurance XApp, and mobility management XApp and handover optimization XApp also, and the anomaly detection XApp and security management RApp. So these are some potential scenarios or use cases that we can see, like where multiple XApps or RApps has been employed to enable the intelligence and to optimize the RAN performance. However, we are seeing that bringing XApps or RApps and dealing with the drift is somewhat critical to address. So can you please go to the next slide? Yeah. So we are just some challenges we have we were presenting here, like interference with the other XApps or RFs. Like drift in one XApp or RF can impact others that rely on its outputs or share data or resources. And the other is that compounded drift. If we see here, like one XApp or drift in one XApp or RF can cascade or causing drift issues across interconnected X or RFs. So these are some observations, some of the challenges that we encountered. And the key, like, can you please go to the next slide? Yeah. So some strategies we are just proposing, like we just want to present, but basically here, like the ORAN Alliance and especially in the working group 2 and 3, that they have been it has been elaborately discussed about the AML model training, offline AML and the deployment, but it has not been discussed about what are the cases that to be considered, or what is the scenario after once we deploy an XApp or RF, and how to ensure that they always perform, they always maintain the accuracy without causing any drift. So we figured out that gap and present here. And here mainly, like some strategies we are providing about drift handling, especially in the context of multiple XApp or RFs. So the centralized drift management, where it can monitor and manage drift across all XR or apps from a single system, or we come up with some more intelligent or detect and isolate drift in individual XR or apps to prevent spread. And the inter-app communications, we can say that isolation of the XApps, create protocols or for XApps to share drift alerts and coordinate responses. And adaptive models we see, like implement online model learning, transfer learning, or ensemble methods, so that they can adapt with the changes in the user traffic. And also cross-app validation we see, validate and adjust for drift impacts across RFs or XApps, or periodic retraining. Going for periodic retraining has its own advantages as well as disadvantages. And the global optimization, use algorithms for global adjustments considering drift across all XR RFs. So can you please go to the next slide? So these are we have determined the potential gap about the drift handling in the context of Open RAN, and especially it is crucial because it can impact the main objectives of the ORAN, where we are bringing intelligence. But in the real time, if we did not address the drift issue, maybe we encounter more challenges, and maybe the aims that we are like our aims in bringing intelligence might be having some issue. So I think we are bringing, like so far we see that even my PhD thesis focused on the single XApp or RF performance degradation only, but now the issue is like how to deal with multiple XApp or RF performance degradation, and coming up with some standardization scope. Like if we have some clear standards about drift management, drift handling and all, that could be very much, I think, that standardization efforts where it can come up with unified drift management standards and interoperability protocols, so that it can avoid the compounded drift, that can avoid the spread of the drift from one XApp to the other XApp, and conflict management among the XApp or RFs, and building real-time testbed setup so that we can see in the real time how it could impact. So those are some of the insights from our end, and comments. Yeah,
Thank you. Yes.
Our team, Professor Koteshwar Gudepu also is in meeting. He can also address some of the queries.
Absolutely.
Thank you.
Hello, greetings to you. Alex and Mehmet, I'll yield to you first. I think, very high level, it looks like a very focused contribution, highlighting a key problem or gap. So Alex and Mehmet, please.
Yeah,
comment.
I would say that there's there are plenty here. At least I see clearly a recommended practice as minimum, and probably standards too, or maybe like recommended practice as a starting as a kind of architectural project, and then spin off specific standards where applicable.
Mehmet is not in the call.
Can you hear me?
Yeah, we could hear Alex, but Mehmet, Alex, were you done speaking or are you still speaking? Because we could not hear you for 2 minutes.
My camera just quit, so I didn't know whether you got
it. Please continue. Please continue.
No, I'm done.
Okay. Now, I heard you saying recommended practice followed by standards. I also think there are elements of this contribution could potentially be standardized, and this itself stands by itself. In my view, drift management is an important, so you have a modeling, whatever solutions you have. Mehmet, are you there on the call? All right. So as I have a few comments around, I know you've done a pretty interesting gap analysis that helps to make sure this work we are doing is not duplicating any other thing, but we are adding to the existing solutions, right? And that sense, you can start with the recommended practice, but Alex also suggested it could be a potentially a PAR item, right? So we can send you the PAR document that Dilip was showing this morning. You can start filling it out while you're writing some kind of a 3 to 4 page type recommended practice, unless you already have written up. Those will be my recommendation going forward.
Ashutosh, recommended practice is also a part. We have recommended practice, we have guide, and we have standard.
Okay, I see.
It's a regular project, but it's not a standard.
Okay. So that can still be part of is an output, right?
It's right. It's just bona fide project for us.
Okay, I see. Yeah, so that could be like a short-term type goal, right? Short-term.
Right, because I would like to know, is there now any kind of write-up anywhere or any kind of document guiding drift management, or it's just completely new?
Venkateswarlu, there's a question to you. Is there any write-up related work and things like that, I think?
Yeah, Professor Alex, so far, even my PhD work was focusing on drift only, but we mainly, in our investigation, what we have observed, especially in the 5G and beyond networks, we see that only single accept, mainly focusing on the single accept, where especially about the QoS prediction, those works are only existing. But moving towards the multiple accepts or RFs, drift management is, I think there is a certain gap in that. That's where we are heading towards, and discussing that.
So this is why I would put up like a recommended practice or guide. It's up to you. And then when it's, you see that it's kind of has a traction, makes some noise in the industry, then you produce standards.
Yes.
That support one or the other solution.
So Venkateswarlu, let's do that. And again, while you write the recommended practice, if you have a work in progress paper, we can still publish in Tech Focus just to add to your work, and then you can maybe we can schedule a time with you, one of the monthly meetings, to go over the document if you have a draft.
Yeah,
Yeah.
yeah, bro. Yeah, we had one.
Okay.
So yeah, we have listed out like recently uh, around 50 to 60 works mainly dealing with the drift, but that is across all the domains. But focusing on 5G and beyond, where there are very few works, and we are fine tuning them and putting in a proper documentation, like what are the various uh, up, like various approaches that other researchers has been proposed and used in the system.
Sure. I think it'll be an interesting contribution.
Yeah.
So with that, unless anybody has any questions, comments, thank you very much for spending time.